Hello all. So good morning. Today this semester it's a new semester, and in this semester you are going to see transforms and partial differential equations. So transforms and partial differential equations. So what are the things that is involved in this? So what are the units that would be covered in this topic? We'll first talk about partial differential equations, and then you'll talk about Fourier series. Third one, it is about classification of second order linear partial differential equations. And on fourth unit, you will see solution of one dimensional wave equation. And on fifth unit, the solution of one and two dimensional heat flow equation. You will be seeing that. Okay. So on sixth unit, you will be seeing Fourier transforms. So these are some of the textbooks, and these are some of the reference books given to you. So unit 1, partial differential equations. So what are the things you will be seeing this partial differential equation is that formation of partial differential equations and solutions for standard types of first order partial differential equations, Lagrange linear equation, linear partial differential equation of second and higher order constant coefficients of both homogeneous and non-homogeneous. Okay, so mathematics. When mathematics was introduced to engineering students, the first question that has arrived in our mind will be, why should I study mathematics? I am a civil engineer, so why should I study mathematics? So to put it simply, you are in a sector where you will be building many of the major public works, like you'll be building a bridge. Sometimes it will be about transportation, sometimes it would be about dams and tunnels, airports. These everything comes under this civil engineering. So when you are constructing something, the basic thing it would be the designing, right? So in that designing, sometimes it involves some critical complex things. Okay, so to make yourself more expertised in that field, you will be studying this mathematics, because somewhere when you are in critical position, you want to study something or you want to learn something for your new project. If you have a glimpse of what are the usages and how it would be used and what are the basic criteria to be used, when you learn all these basic things here, when you are applying on your project, it would be easier to model it accordingly. So that's why you need math. Next question is, why partial differential equations? Okay, I'm a civil engineer student. I want to study mathematics to learn some basic mathematics things. But why partial differential equations? This is the question, right? So the civil engineers use this partial differential equation in many of the fields. Like you'll be using this in heating and cooling, motion of particle in resisting medium, some in hanging cables, some in electrical circuits, some in natural purification in a stream. Like it's a process. So whenever there is something involved in designing something or building something, there would obviously the usage of partial differential equations will be there. So what is partial differential equation? So in a differential equation, if there are two or more independent variables and the derivative or partial derivative, then it is called as partial differential equation. So if there is a equation given to you and you will have two or more independent variable and you will have a partial derivative also there, and that is known as partial differential equation. I have given an example here. Go over the first example. You will have dou square z divided by dou x square the whole square plus dou square z divided by dou y square the whole cube. So this is a partial differential equation. Why this is a partial differential equation? Because that z is a dependent variable, x and y are independent variable. So there are two or more independent variables. You have x is an independent variable and y is another independent variable. So two or more number of independent variable. You can see on the second example, there is x, y, t. There are three independent variables. So two or more independent variables should be there, and the next condition is it should have a partial derivative. Dou square z by dou x, dou z divided by dou x. So the partial derivative is there. So therefore this is a partial differential equation. Next, order and degree of partial differential equations. So what is the order? and what is the degree. First you have to find the order, then it would be easier for you to find the degree. So to find the order, if the order of the highest partial derivative occurring in the equation, take an equation, from that equation just go with the highest partial derivative, so that order will be the order. Okay, so that greatest exponent of that highest order will be your degree. For example, likewise the previous example I have given here, dou square z divided by dou x square the whole square plus dou square z divided by dou y square the whole cube. It is given here, right? So in this, first you have to find a order. So how to find the order? You have to find the highest partial derivative. So this is what is the highest partial derivative here? This is the second order equation. Derivative means first that y is a derivative. Okay, so y dash is a derivative, y double dash is a second derivative. We'll differentiate, right? So that differentiation is a derivative here. So it is differentiated 2 times over here. So dou square z divided by dou x square. So it order is 2, and in that order what is the highest greatest component exponent? What is the greatest exponent here? 3 is the greatest exponent here. So the order is 2 and degree is 3. And for second example also you could easily say the order is 1 and degree. Now, so how to form a partial differential equation? So partial differential equation will be formed by two type. Type 1, it is by eliminating the arbitrary constant, and type 2 by eliminating the arbitrary functions. Okay, so first you have to know the symbolic representation, in which places how we will use the representations. Okay, for example, z is the function of x and y. Okay, so if you want to differentiate the function z with x, you will put it as dou z by dou x. Again you want to second time differentiate that z with x, you will put it as dou square z divided by dou x square. Okay, for that same z, if you want to differentiate with respect to y, you will put it as dou z divided by dou y. If you want to differentiate the same one again with y, you will put it as dou square z divided by dou y square. If you want to differentiate dou square z with x and y, you will put it as dou square z divided by dou x dou y. Now this is a simple question, like which contains the variables and partial derivatives. Obviously partial differential equation should have the variable and the partial derivative. Okay, so the greatest exponent of the highest order will be your degree. In this equation you have to find the order and degree. First you have to find the order, then you can find the degree. So how to find the order? First you have to find the derivative. Which derivative is given here? First order derivative or second order derivative? First order derivative. So the order is 1. And what is the exponent of that first order derivative, highest exponent? It is 3. So 3 is your degree. Thank you.